Welcome to another 3D video from RPS Maths Lab. In this video, today we'll learn how to locate points in 3D space, measure the distance between them, and verify our results using distance formula, all with a simple physical model. To make this learning hands-on, we are going to build a simple 3D model using everyday items such as a cardboard sheet, incense stick to represent the z-axis and the distances, a scale to measure the distances. Now, for example, if you have to find the coordinates of an edge of a cuboid having dimension 3 cross 3 cross 5, placed in such a way that the base is a square and the square lies in the fourth quadrant. So the xy coordinates, if you see, is 3 in the positive direction, minus 3 in y direction, and 5 in the z direction. So the coordinates of this edge should be 3, minus 3 and 5. So similarly, if you want to find the location of a point in space given the coordinates minus 2, minus 3 and 1, so it would be lying in the third quadrant having a vertical distance of 1 in the z-axis. So let us imagine the cardboard as the xy plane, and there are 4 given points: minus 2, 2, 2, minus 2, minus 3, 1, 4, 1, 3, minus 3, 5, and 4. So to actually try to locate them in space, we need the projection of these points on the xy plane and then use an incense stick upright to show the z direction. So if you try to find out these points, we'll first mark the xy coordinates on the xy plane and put an incense stick to get the upright distance of that coordinate. So when we mark minus 2, minus 3, and to get a z-axis vertical height of 1, we put this incense stick such that the vertical height is 1. So this point in space would be minus 2, minus 3, and 1. Similarly, if we go on to the next point where we need to find the point minus 2, 2, and 2, we'll place the incense stick at this coordinate minus 2 and 2, and the z-axis distance would be 2 centimeter. So we have already measured and marked 1 centimeter, 2 centimeter, 3 centimeter, and 4 centimeter on this incense stick. So I'm able to identify this position until where I need to put this incense stick inside this plane. So this is the third point, which is 4, 1, and 3. Now for the final point, which is 3, minus 5, 3 in the x-axis, minus 5 in the y-axis, and the vertical distance is 4. So these are the 4 points, and we need to find the distance between these points. So if you see that to find the distance, it is in space, we need to measure, say, if we want to measure the distance between 2 points A and B, which is minus 2, minus 3, 1, and minus 2, 2, and 2, So these 2 points, we'll use the distance formula. These are the 2 points, A and B, which is correspondingly here A and B in space. The projection is L and N. So if we try to measure the distance between A and B using a scale, it comes out to be 5.1 centimeters by observation. Okay, now let us try to use the distance formula to get the distance between these 2 points. The distance formula says the distance between 2 points in space is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square root over. Okay, so x2 minus x1 whole square is minus 2 minus of minus 2, which is 0. Whole square is again 0. y2 minus y1 whole square is 2 minus of minus 3, which is 5 square. And z2 minus z1 square is 2 minus 1 square. It is 1 square. So it is root over 26, which is approximately 5.1 centimeter. So as we can see, the distance we measured with the model closely matches to the calculation using the distance formula. You can also try to find the distances between the other points and verify whether this is actually matching or not. So if by observation we go and check the distances between, say, another 2 point, which is A and C. So if we try to measure the distance between A and C, I'll put this model down and try to measure it. So it's approximately 7.5 centimeter. So you can do a calculation for the coordinates of A and C and find the exact distance. We can also check the distance between C and D, which is here. So distance between C and D, we'll try to measure the distance between C and D. The distance between C and D is approximately 6.1 centimeter. So you can also check various other distances using the distance formula. So this activity has real life applications too. For example, when the engineers are building structures like towers and bridges, they need to calculate the distance between these points in 3D. And yeah, so today you saw how to bring a math to life using a 3D model. This isn't just the theory, it's like a geometry in action. So like, subscribe and share for more hands-on maths videos, and do not forget to explore the world around you. It's all built on geometry. Thank you.